Hydrogen peroxide technology. We have been refining our current hydrogen peroxide technology for more than 30 years. Today we offer our customers hydrogen peroxide that is produced using an energy efficient and cost effective solution. The most common method today for producing hydrogen peroxide is the anthraquinone auto-oxidation process. An anthraquinone solution, also referred to as the working solution, continuously circulates in a closed loop and is the carrier for the controlled reaction between hydrogen and oxygen. Hydrogen peroxide is produced in a five-step process: hydrogenation, oxidation, extraction, drying, reversion, distillation, according to the following simplified reaction: H2 plus O2, H2O2. Thanks to our patented fixed bed catalyst, we have improved the hydrogenation process and avoid the need for a complicated filtration process. We achieve highly efficient use of raw materials and energy from this easy to operate process. हम सबके कायद आज के दिन हम तुझसे वादा करते हैं हम तुझसे वादा करते हैं Hydrogen peroxide is a weakly acidic, colorless liquid miscible with water in all proportions. It is the simplest peroxide molecule containing two hydrogen atoms. Step 1. Hydrogenation. Palladium catalyst the reaction between H2 and the anthraquinone to create anthra-hydroquinone. Step 2. Filtration. The palladium catalyst is filtered out of the solution. Number 3. Oxidation. The solution is oxidized by blowing air through the solution. Now, step 4. Hydrogen peroxide is removed in a liquid extraction column and concentrated by vacuum distillation. The manufacturing process. Hydrogen peroxide is manufactured using the anthraquinone process. This is a cyclic operation where the alkyl anthraquinone is reused. The synthesis loop consists of sequential hydrogenation, filtration, oxidation, and extraction. के दिन हम तुझसे वादा करते हैं तुझसे वादा करते हैं. The hydrogenation stage is carefully controlled to avoid overhydrogenation of the anthraquinone rings. Basicity and moisture content are important for optimum catalyst and activity. The working solution containing the dissolved anthraquinone is hydrogenated using hydrogen gas in a slurry-type hydrogenator using alumina loaded with a small amount of palladium catalyst. Temperature is controlled to around 45 degrees Celsius and the reactor is agitated to ensure good mixing of catalyst with working solution and hydrogen. During hydrogenation, the alkyl anthraquinone is converted to both the alkyl anthra-hydroquinone and quinone and the tetrahydroalkyl anthra-hydroquinone. Although production of the tetra form of the quinone is preferred because it can be more easily hydrogenated. अबे पेशला दिया इसने तेरी गान को मारूं भोसड़ी के तेरे टट्टा बच्चाड़ों. Filtration. The working solution that now contains hydrogenated anthraquinone is then filtered to remove any trace levels of catalyst. If the catalyst is not removed, then it will decompose the hydrogen peroxide in later stages, reducing yields and causing potential hazards. Oxidation. The working solution is oxidized by blowing air through it. The tetrahydroalkyl तेरी बहन को चोदूं is due to extraction since the hydrogen peroxide is present in an organic phase and the product is required in aqueous phase. Demineralized water is added to the top of a 35-meter high liquid-liquid extraction column. The water flows down the column over perforated trays where the working solution is pumped up the column. The extractor design and operation ensures a maximum contact of water with the working solution. The water reaches the bottom of the extractor and contains 25 to 35% of crude hydrogen peroxide, whilst the working solution that leaves the top of the extractor is free of hydrogen peroxide. The crude hydrogen peroxide is subsequently purified and vacuum distilled to concentrations of up to 70% weight. This concentrated product is stabilized against unwanted decomposition by adding proprietary stabilizers and then pumped to product storage tanks for final testing. Utilities. The synthesis loop and peroxide processing stages are dependent on a number of ancillary processes. Hydrogen plant. This plant processes natural gas through a steam reforming stage and subsequent high temperature shift catalytic stage to produce high purity hydrogen gas. This gas is finally purified in a pressure swing absorber before being used by the hydrogenator. Details of this process can be found in the manufacture of methanol. High purity water is used to feed the extractor, concentrator as well as the package boiler. Conventional degassing following by cation and anion exchange beds is used to purify town water for use in the peroxide process. A package boiler, a small boiler generates steam for use in concentrating crude peroxide from 25 to 35% is 35 to 70% waste gas system. The oxidizer can produce an exit gas containing trace levels of solvent. The solvent entrained gas is fed to a bed of activated carbon where the solvents are absorbed onto the carbon. The activated carbon is purged with nitrogen gas and the solvent is stripped off and recovered for reuse in the synthesis loop. Calciner system is used to regenerate spent catalyst on a periodic basis. The catalyst is removed from the regenerator, is washed and roasted. Fire system. The hydrogen peroxide manufacturing process uses natural gas, hydrogen and organic solvents.